Hello, welcome to our presentation on Tassomai for Maths. Just by way of content, I'm going to introduce myself and talk about the program and what it does, not just what it does, but how it works and why we've seen it work so well when it's been well implemented. We had an earlier presentation in the day where we talked about the importance of evidence and EdTech, and we went into some detail about some data studies we've conducted. I'll very briefly touch on that, but leave some time for Q&A at the end. So thank you for joining us. By first of all, way of introduction, my name is Murray Morrison, and I am the founder of Tassomai. I was originally a teacher of maths and science, and I produced the first version of this software really as a way of trying to help my students improve their attainment in those subjects. So I designed the teaching and learning algorithms and wrote all the original content. We're now a much bigger team of sort of a dozen people, and we have better writers than me putting the content together. Chris, who is not presenting today but will be available for Q&A and would be kind of the main point of contact if you were looking to set up a trial of Tassomai. He's an ex-English teacher. He loves maths though, not really. But he runs our CPD and training and customer success along with Min. So that's the sort of face of the company that you would be meeting if you were to take a look at the program and try it out in your school. We do, of course, run free trials for you to take a look, especially with a new product like our KS4 Maths, which is the purpose of today's presentation. But first of all, just a brief overview of what Tassomai is. In a nutshell, as it says on the slide there, we're an app. We're an app that's used on mobile phones. We're an app that's used on any internet-enabled device, particularly desktop computers. And we're an app used by students to complete practice assignments that personalize to them. So we're what's called an adaptive or intelligent EdTech solution. We're most well known for our science product, that being the one where I knew quite a lot of science teachers and kind of got that sort of first leg up, and we had a really kind of viral word of mouth spread around the country. We're in over 500, in fact about 700 schools since the coronavirus situation hit. So we're well used in science departments around the country, less well known for, but in recent years doing English and maths at Key Stage 3, and we now really launching our Key Stage 4 English and maths product, which is what this presentation is largely about. So to see how it works, a sort of lightning tour, you'll be glad it's an extremely quick tour. Students use our app to do quizzes, and the quizzes are very cleverly designed to tailor to the gaps that they've shown in the knowledge. So we're always monitoring what they know, what they don't, what they've practiced recently, what they need to brush up on because they haven't done for a while. And we essentially design the daily activity to balance or keep all those plates spinning and get them to do a daily quiz. So it just sort of engages them in a little bit of light practice that's getting them to continually sort of update their knowledge, fill in gaps. And of course, the program will identify gaps and sort of scaffold the content to give them a little bit more help where it's needed. I'll go into that in a bit more detail later on. That's what it's doing for the students. And of course, if it identifies a problem area, it will put a little video up that might have somebody like, I don't know who this guy is, teaching them what they, a little topic that they've shown a gap in knowledge in. And we've done evidence research that's shown that's really impactful on their knowledge and retention of knowledge. We then will give teachers dashboards that show who's been doing the work. Obviously, if you're going to use this as a homework tool, you want to know who's doing the homework. You get instant access to that data. But much more excitingly, from my point of view as a teacher, and I'm sure from yours too, it's the RAG rating, it's the assessment of who needs help and where that's really crucial. If, and we really hope it doesn't come to it, we're going to have more distance learning next year or more blended learning, then keeping a really accurate monitor on who's struggling and where the gaps are is, of course, really crucial if you're going to plan the intervention for what little time you have with your students. So the data that shows here are the gaps are really important. Now, teachers don't really need to action that data if they don't want to, because the app is, of course, doing it for them. But if you're planning intervention, or if you're planning reteaching or revision sessions, or just if you have a few minutes with one of your students to kind of drill into a problem area, all that discovery work's done by the app, which allows you to really do the intervention and do the teaching part. There's another bit to this, which is an extra bit to the slide, which is that we also aggregate that data for school leaders like yourselves to see exactly where in the school it's being well used. This is real data actually on the screen from a school where it was adopted for a trial. You can see initially there's one green stripe where one teacher is really championing it, doing brilliantly. Word spreads, and you can see, because this data is also being shown, that more classes start to adopt it, engagement goes up, and you can see the sort of increase in green colours. You get that kind of live data every week, but that also gives you leaderboards, assembly, raffle prizes, all that sort of thing as well. And that's aggregated even at the MAT level so that you can compare school to school if you're in that position too. Tassomai is used in around 500 schools, including here at St Thomas the Apostle School in South East London.
I can remember these in the exam, and it does help a lot.
Sometimes maybe my mum will think I'm playing around, playing games with my phone, but I'm actually doing Tassomai.
Students were putting in an hour and a half, some students 3 hours of revision a week, and then seeing that their results actually were slowly improving. It didn't happen overnight, but those results started to creep up, and we were generally surprised at the end of the day how well some of these students performed.
As the questions get progressively harder, I feel myself getting challenged, which really helps with my revision. And I've seen results with my mocks, my recent mocks, so it is really helpful.
Yes, I've seen a big improvement in my grades and in my way of remembering things. I'm able to remember bits that I normally would forget on a repeated basis.
I can't imagine not using Tassomai because it's really interactive and actually fun to use.
In building our programme, we've used methods identified by academic researchers as the best ways to learn. One of Tassomai's key principles is that practice makes permanent. And you can take a lot of inspiration from the way athletes and musicians go about this. There's a good quote which is that an amateur practices until they get something right and a professional practices until they can't get it wrong. That's what we're trying to get you to do with your revision.
So when I opened my results, I was really shocked, very happy. I managed to get an 8 in chemistry and 7s in biology and physics, which I wasn't expecting at all.
I certainly would recommend it to another school. I don't know if I want to though, because we're quite high on the school league tables, so maybe we want to keep it a secret.
Tassomai isn't a silver bullet. Academic attainment only happens with dedicated teachers and willing learners. But what we can offer schools and families is a method, a programme that's shown to improve attainment. And in the right hands, it's extremely powerful. So as that video showed, we are very pleased to have been a really indispensable resource for GCSE science for years. We know we have an impact, and especially when it's well used, it makes a tremendous change and impact in attainment grades for students and their schools. It's a shame that those students at that school weren't able to see their real GCSE results this year, but of course we know that it is having an impact. It's seriously boosted their mock exams, and teachers were able to use our data, in fact, to do their centre-assessed grades as well. So. But that's our reputation in science. We have another reputation in science which is for being expensive. Actually, that's rather unfair in that now we're used across 5 cohorts, and for 3 subjects we come out at considerably less than £2 per student per year for a subject. So, you know, it's quite affordable and has real impact. As we've grown as a product, we've really increased our value. Here are a few just testimonials of you know, how it's affected people's outcomes, both from a teacher, a student and a parent. And if you visit our website, of course, it's flooded with testimonials from practitioners and users. This one we want to put here though, because we started working with schools last year, rolling out our Key Stage 3 English, Maths and Science, and this is really meant to be about maths, of course. Here's a school using Tassomai in Taunton who saw for their students across the board, across the 3 subjects, having a real impact and really starting to raise attainment. And building that kind of foundation knowledge at Key Stage 3 was shown to be really valuable. On the back of that, we knew we had traction, we knew we had interest from maths teachers and English teachers, and we sort of gathered a lot of research and feedback and started to build our Key Stage 4 products, and those are what we're going to make available for this coming academic year. It is included in the package at no extra cost, so essentially we're tripling the value of the product without raising the cost. So we'll look now at our maths product and just show you a little bit more about what it is. You can see in that screenshot there and a kind of example question where it's asking students to fill in the blank. Well, the formula 2πr gives the what of a what, so they're sort of connecting those two areas. I'll show you in a bit more detail about how those questions start to synthesize from smaller knowledge points. But essentially, Tassomai is built up of this kind of low-stakes, high-frequency adaptive quizzing that does a number of jobs. First of all, it simply improves students' base knowledge and recall of facts. And what's really important to me and was so important for my students was it's not just having the knowledge, but it's knowing you know things. It's the raising of confidence that students have where they know that their base knowledge is on solid foundations. And that allows them to start kind of being more creative in their problem solving or thinking a little bit more complex ideas using that base knowledge because they know it's sort of securely it's secured in their sort of knowledge. So we sort of improve that base knowledge, we fill in knowledge gaps, we give feedback, we build confidence, but then also because of the data we give to teachers, we allow teachers with a self-setting, self-marking homework, save tons of marking time, but also start thinking about planning and streamlining intervention and focusing in on students that need it. It's been shown to have enormous impact on attainment, but also giving you as school leaders or middle managers the engagement and accountability data that helps you kind of make sure it's well implemented. No point in buying a package like this if you're not going to use it well, so we just kind of give that kind of data as well, of course. So we're being responsible to you as customers. Now that's just sort of what the program is. How it works is kind of a bit more interesting to me. Although I taught science and maths, my real passion was sport and music, and I really studied the way athletes and musicians practice as a foundation for trying to help my students master knowledge. So it's all based on a practice model, and the famous sort of expression that people say as practice makes perfect, it absolutely doesn't. Practice makes permanent. So it's only perfect practice that makes perfect. You've got to have practice with feedback to really learn well, and that's the fundamental idea on which Tassomai is built. Now, I built it with multiple choice questioning. Lots of people take rather a dim view of it. Used the way our platform uses it, multiple choice is extremely powerful. We'll talk a little bit about why, but essentially, and I'll show you some examples, the content in our multiple choice questions is really just a torn up version of the textbook. It's a textbook in disguise. You saw in that one example there, filling in the blanks of what 2πr represents and having to put together two things, not just circumference of a circle, but trying to make sure you're not saying area of circle, area rectangle, and put these ideas together. It's engaging students in that content. So if we were just serving content as videos, people would disengage, they'd press play and then they'd go and look out of the window or do something else. But also, because of the multiple choice aspect of it being very quick fire and low stakes, we're able to present big ideas in small ways and incrementally build students' knowledge, but also be extremely adaptive in the way we can maneuver students through that learning pathway. We can ensure they master essential facts before we build on them, but we can also sort of build that scheme of work, if you like, for every student in a really focused way. And as for laser focused here as well, it's more to do with content specification. So particularly in science, where we started, the specification just between boards and even between sort of the flavors of the boards was very different from one to the next. So the multiple choice format allowed our content to be really, really focused on what was required without any kind of fat on there to be cut away. So it was really an efficient program. It also, through our multiple choice, allows us to give really immediate feedback. So every question a student sees is instantly marked and they get that feedback. They're able to review mistakes instantly. But we also use feedback mechanisms to change and differentiate difficulty. So to boost and stretch students where they show improvement, or to scaffold where they show gaps in knowledge. If we show a particular weakness in knowledge, we can give them instructive videos. We're building more and more videos on the platform every day. Well, not every day, I wish, but under coronavirus lockdown, it's slowed down a bit, but we are building lots of videos and we continue to add them. So we'll be adding maths and English videos as well as our science ones. But those videos are really specific, 1 minute to 1.5 minutes. So they can really speak to the gap in the knowledge and fill in that gap. There are other feedback mechanisms at play as well, of course. The rate at which content is spaced or interleaved for students tailors to their specific level of attainment recently in that topic. So if they show a gap, we can circle the wagons and give them high frequency scaffolded content in that area. If they show improvements, we can start to increase the spacing, interleave with other topics and so on. But the most important feedback mechanism is, of course, you and your staff, the teachers in the classroom, who can use the data we accumulate and can feed back to allow your teachers to really have impact where it's needed. They can say, right, I know this topic needs teaching for this group, or I can split the class and see all my blue dots can do peer mentoring with all my orange dots, and use the data we provide to really make the most of the time you have in the classroom for any intervention that you have. Now, did talk a little bit about question design, and this is where we just go into a little bit more detail. There are lots of programs that might look a bit like Tassomai. They're not the same. We really are sure of the fact and proud of the fact that we're the best package out there. We can just go into a little bit of detail as to how. So I give here an example question. I think of questions as being like cards. In fact, the first version of Tassomai I built was a card game, and it's a sort of lightness system, but lightner times 1,000, or a sort of pan-dimensional lightness system, if we like. But essentially, if you think of questions as being like cards, well, here's an example card, a fairly basic example for maths. A squared times a cubed is what? And we have these 4 options. Now, the this can't be simplified option is a good distractor, I think, because we'll have another question that says a squared plus a cubed, and that can't be simplified in that sense, not without knowing what a is, at least. So it can't be algebraically simplified. Anyway, there is a correct answer. I hope I don't embarrass myself by saying it's a to the 5, but let's see what the student in our mock-up picks. Well, they pick a to the 6. Now, why do they do that? They probably multiplied the indices. They might have mixed it up with a squared times a cubed, a squared to the power of a cubed, which would be another question. So we see that mistake. We'll, of course, immediately give them the correction, but it's more than that. The feedback mechanism then starts to introduce another question. Now, here is a more classic Tassomai question. It's not just testing of knowledge point, it's teaching them something and then asking them something about what they've learned. So a squared times a cubed is a to the 5. This demonstrates that in this kind of multiplication, indices are, well, this is easy to get right now because you can just read it. Well, we're clearly adding. So it's filling the gap. But do you see how that's engaging students in essentially the written content? This could have been a complete sentence and stuck into a textbook, and you know as well as I do that the students that most needed to read that sentence are probably going to skim over it and not take it in. But if it's in the form of this question, they really are going to go, oh, this is an easy question, it's added, obviously, and they get it right, and they get that positive feedback, and they've engaged with the content. That's the power of this kind of low-stakes multiple choice when it's written the right way. Now, it will, of course, be giving them that first question again. And we'd hope, and our data shows they're far more likely to get that first question again. They've had the corrective feedback, they've had the scaffolding question. Both questions are going to be in rotation. And now we're going to sort of synthesize this knowledge a bit with something a bit more taxing, what we call a binary question, as in it's got 2 blanks and 4 possible combinations of answers. Fill in the blanks. Now you've got the general formula, a to the m times a to the n is a to the n plus n, I hope, and therefore, and here's applying it to a different question, a cubed times a6 will be a9. But you'll see the options are all the permutations. So there's lots of room for going wrong, and students have to pick both bits. So a to the n plus n, a to the 9, and they've got that right. And they don't just have to get it right once, they do have to get it right several times over increased spacing intervals. If they make a mistake, the spacing changes. You can imagine how that goes. It's exactly how you would design the system if you were trying to design the system, I would hope. We test this with lots of teachers and get that kind of confirmation all the time. So that's the kind of idea. And that's going on in what we call a knowledge point. Do they know the law for multiplication by adding indices? Well, that's going on in one knowledge point. It's also going on within all the aspects of algebra. And in this example, our number knowledge, where there's a whole deck of cards on number knowledge, factors and primes and multiples and highest common factors and so forth. And those questions will all be being not shuffled, but ordered, if you like, in a deck of cards. And they'll be shuffled. They're not shuffled. They're very selectively ordered for each student. They're being ordered with lots of different factors at play. So recent errors for correction or elaboration, the kind of thing you saw me expand on there. They're selected for the appropriate level of difficulty to scaffold or stretch, as I mentioned before, and with a recency factor too. So we're thinking about the spacing intervals that need to increase to kind of match our sort of model of the Ebbinghaus forgetting curve. So if you made a mistake, we'll come back for early feedback. If you corrected a mistake, it might come back for early confirmation. But then once you're showing that you know it, it'll start to stretch to test your memory. Now that's going on in every topic. Every deck of cards is being ordered like that. These are maths decks. It's just an illustrative example, if you like. I confess I've made up these sort of question allocations just for the sake of the presentation, but it's a fairly accurate demonstration of a kind of maths content. And then those decks as well are being shuffled in between each other for very similar reasons. You know, which topic hasn't been done recently, which topic has shown like they've recently kind of dug into a seam of problem questions where they need more effort. But also things like whether the exam date is coming sooner in one than another. That's particularly pertinent in biology, chemistry and physics. In science, where the exams are at different times, will obviously accelerate the priority of the B1 content as we get towards exam time over the P2 content, which is they have a month more to do that. So all those other factors start to balance things. And then what I haven't got a slide for, it's labouring the point rather, if you've got students doing English, maths and science, then those three topics are also to some extent being favoured for their frequency and spacing. So that's a kind of example of how the programme works. My students that I worked with, particularly while I was developing the software, were a very interesting bunch, often excluded from schools for behavioural reasons, and I had to sort of work with them in the home context. And this is where we get into the why. My face, I realise, is going to cover the first bit of this, but this is really important to me. It's not just about knowledge rehearsal recall. This is about kind of building a mindset. That first graphic, you're just going to have to take my word for it, it's really cool. It says deliberate practice under my face, just about here. Deliberate practice. This is the idea behind the program. Again, I looked at how musicians worked, how athletes work, and they're engaging in deliberate practice. They're really cognizant of what they're doing. They're thinking about the steps, and they're thinking about each action they're taking, whether it's playing their instrument or doing their sport. So deliberate practice is at the heart of this, and I have a lot of experience in those arenas with sport and music, and I built that into this kind of model essentially. Now if you've got deliberate practice and you can build it into a routine, and you'll look at our user experience, our sort of the way the program works, it's all about daily goals, achievable, little and often practice. These routines become habits, habits become behaviour, and behaviour, if it's implemented across a school, becomes the culture of the way a school learns. And this is a really important tool in the toolbox of a department or a school. Now, you combine those things, the regularity of engagement and the deliberate practice approach, students start to engage better metacognitively. They start to become more aware of how they're learning, what their actions have done to affect their level of attainment, where their weaknesses are, where they maybe ought to go and do a bit of extra work, and where they're struggling, which topic they hate seeing come up all the time because they hate it, because they can't do it. Well, now they're kind of more aware of that. They're going to go and do some extra reading or watch the video when it's prompted. But the really important thing to me is more around this kind of idea of self-directed study. The students are doing this, they are empowered with an app like this. We, the algorithm, are doing all the organising of it, deciding what they should do. They are just logging in and pressing go on the day's exercise, but they are doing the work. It feels empowering for them. And as a result of the achievement they make through this, they're truly confident as a result of their work. It's not the kind of thing where they feel that these improvements have been handed to them on a plate through a ton of intervention. They really feel like they've earned it. They've done it. I've seen this happen thousands of times, hundreds of times with my own students and thousands of times with the students who've used it since. Now, I'm going to skip through this because I've been talking a long time, but these are all data studies and evidence that are given in much more detail on our impact report that you can see on our website. I also talked about in our earlier presentation. We've shown Tassomai to have a serious impact on outcomes. We did further research on how these students actually changed against their prior attainment, so to look more about improvement in outcomes rather than just raw grade outcome, to try and remove some of the kind of causation, correlation questions. And we showed Tassomai usage did have a genuine impact on the rate at which student attainment changed. The more they used it, the more they improved. We also completed a study recently that looked at our dots, our sort of predictor of outcomes and how that translated to real outcomes in independent assessment. This was mock papers, about 6,000 mock papers that we looked at on a question-by-question basis to see, well, if we had an orange dot in this question on this topic and the question asked about that in the exam, how likely were we to have predicted correctly they were going to struggle here or do well here where we had a blue dot? And the answer was really quite well. I mean, given the amount of noise that you would expect to see in a study like this, we were very pleased to see that. But we also saw some outliers that allowed us to develop our product further. We now no longer are going to show tiny red dots that indicate a problem if in fact it's too early to call. Our data and our research showed that that was a dangerous thing to show, so we've removed that. But our dots now have been used by schools as well for their centre assessed grades, as well as for planning intervention. It's nice just to have that bit of research to kind of validate that the work we're doing is on the right track. We have a little bit of time for Q&A, but you should feel free, of course, to contact me. I'm Murray, that's Murray spelled like that, and if you email murray@tassomai.com, you'll find me, of course. Likewise, chris@tassomai.com. Otherwise, look forward to chatting in the window here, or otherwise, please do get in touch with us anytime. Thank you so much for your attention. Bye-bye.